Hi there. In this video, I would like to walk you through two strategies towards graphing a transformed quadratic function. The first strategy is just moving the parabola, thinking about what happened to it, what kind of transformations I applied. And the second strategy is using mapping notation. At the beginning, I would like to make it clear that transformations is about changing the parent function. So we have parent function for the quadratic function y equals x squared, and we all know that this is how it looks. And it's worth mentioning the key points of a parent function. So the key points is actually a table of values of those 5 points, which we always sketch when we're talking about parent functions. So we start with -2, and by inputting -2 into this equation, you can get 4. And then if you do the same with -1, -1 squared is 1. 0 squared is 0. 1 squared is 1. And finally, 2 squared is 4. So those are the key points of the quadratic function and of the parent quadratic function, which looks like y equals x squared. So transformations is about changing this equation, and which means that the shape of the parabola change. So let me take the first strategy. And as I mentioned, the first strategy is suitable for simple examples, simple equations. Let's look at this equation. So here we have only one type of transformations. And before I start discussing it, let me remind you the formula which we use, generic formula we use for transform functions. So y equals a, sorry, there's k now, not only a, d, and c. So k times x minus, now instead of h we have d, and then squared plus c. Okay, so if you compare this equation to this generic one, you will see that there is only d value here, and d is, let me use a different color, d is -2, why -2? Because the generic formula has got negative and the new formula has got positive. So negative times negative is positive. So it means that negative value of d has been inserted into this equation. So d is negative. Now, what is a value? So we don't have anything, any coefficient before brackets. It means that a is 1. And then we don't have any coefficient of x inside the brackets. So it means it's also 1. And finally, c is not there. Since nothing is added here, it means that c value is 0. Okay, so now let's think about transformations. What kind of change has been applied here? Remember, this is the graph of the parent function x squared, and we are to graph a function with this new formula. So since the only transformation which is here is the one which d is responsible for, so d is -2, we know that d is responsible for horizontal translation. Horizontal translation, which means just take it and shift it, either left or right, horizontal translation. In this case, d is negative. If d is negative, it means that the shift is to the left. So horizontal translation exactly 2 units left. How will it look like, the new function? You literally have to take all the 5 key points. Let me highlight them here. 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4. And shift each point 2 units to the left. Okay, 2 units left. So it means that the vertex is going to be here. The vertex is going to be here. This point here, point 1, 1 is going to become here. This point, and then point negative 2, 4, 2 units left. And 2, 4, 2 units left. So I got 5 new points of this transformed function. And all I have to do now is to connect them. So let me use a different color for it. Let it be blue. And just make sure that you connect it in a smooth way. Getting a smooth curve. Don't forget to add the arrows at the end. Okay, so this is the first strategy. Just by understanding the type of translation, you shift the parent function graph according to those transformations. Okay, here, for example, the second example here, there are 2 types of transformations. As you can see here, D is positive 1 and C is negative 1. What does this mean? It means that the parent function has been shifted 1 unit right, 1 unit down. So I now do 2 steps move. So I take the parent, the vertex, and move right and down. So I get this new vertex. I get this new vertex. And then I do the same with all the other points. I take this point right down. So I get this point. And negative 1, 1 right down becomes exactly the origin. And then finally 2, 4, I move right and down. This is the new position. And finally, this is a symmetrical point. So by connecting it, I get the new parabola. As you can see, its shape has not changed. What has changed is that it has been moved 1 unit right and 1 unit down. The other strategy which I want to talk to you about is mapping notation. This is strategy number 2. I recommend using this strategy when you have more than 2 types of transformations in the equation. So let's look at this equation, 15. And when you use the mapping notation, you should have the mapping notation formula in front of you. So let me remind you that mapping notation is basically stating the new coordinates for the new graph. So x over k plus d is the new x coordinate, comma, ay plus c is the new y coordinate. All right, so if I just know k, d, a, c values and input them into mapping notation, I will get the new coordinates and I will be able to sketch. So let me state all the values. A is negative 1, we're working with number 15. A is negative 1. K is 3. D is negative 1. And C is 2. Okay? So I always recommend to have the key points table in front of you. You remember negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. And now we show how to move from the parent function key points to the new points. So here in the table of values, I'm going to use the mapping notation for this formula using the values of A, K, D, C, which are given. So it's going to be x over 3, -1, -1, right? And then for y, I have negative y, and c is +2, plus 2. Y is -1 because a is -1, so -1 times y is -y. So what am I supposed to do right now? I just do simple calculations. So I am going to take the first value for x from the parent function and input it here. So I'm going to get -2 over 3 minus 1, which results in -1 and 2 over 3. Okay? And then I do the same with y value. So the y value used to be 4. I'm going to input it here according to mapping notation. So I'm getting -4 plus 2 equals -2. So let me show you, let me highlight the new coordinates. So I got new pair of coordinates, -1, 2 over 3, and -2. So for 2 over 3, you can use the approximation, right? So let it be -1.3. And let me now have this point on the grid. So -1 and third is here, and -2 for y. So somewhere here is my new point. Okay, so I'm going to repeat it 4 more times. Okay, it's going to be so let me do it 2 more times, and then I think you can do it completely yourself. So -1, I'm inputting it here instead of x. So -1 over 3, -1 over 3, and -1. Okay, so the new coordinate is going to be -1 and 1 over 3, -1 and 1 over 3. Okay, so for y value, I'm going to use 1. So -1 plus 2 is 1. Okay, and then 0. 0 is the easiest one. So for zeros, I have, if I input 0, this will be cancelled out, and this will be cancelled out. So for vertex, I have -1 and +2. -1 and +2. And finally, for 1, I have, of course, it's going to be negative. So if I input here 1 over 3 and subtract 1, it's going to be -2 over 3. And then I have 1 here. -1 and 2 is going to be 1. And no surprise, because the rest of the y coordinates are going to be symmetrical. So the last one is 2. 2 over 3 minus 1 is -1 over 3. And for the y value, we have 4. -4 plus 2 is -2. Okay, so I got, let me highlight them. I got 5 new ordered pairs. 5 new ordered pairs, which I will just need to plot on the graph in order to have the graph of the new parabola. Okay, I just want to verify. So for 2 over 3, I think I made a mistake. So for 2 over 3, we should approximate it as 0.6. So for 1 and 2, 1, 2 over 3, when you are going to plot this point, let me erase this first point. So I'm working with the first point now, okay? I'm working with the points -1, 2 over 3, -2. So -1, 2 over 3, 2/3 is not easy to graph. That's why to plot this point. So we'll use the approximation in decimals. So -1 and 2/3 is approximately -1.6. Okay, so -1.6 is somewhere here, and then its y value is -2. So -1.6 is going to be here. So this is my first point. Okay, and then I have -1 over 3 is approximately -1.3. So -1.3 and +1. So -1.3 and +1 is here. And the next point is the vertex, very important point, -1 and 2. -1 and 2. Okay, and this is a bit here. Finally, I have at other points symmetrical, right? Symmetrical. And here. So it's such a narrow, like parabola, which is squeezed horizontally because k is equal to 3. So it has been compressed horizontally by the factor of 1 over 3. So no surprise that we are getting something like that. Smooth curve like that. Okay. So now number 16 is going to be easier. So just try to repeat the steps and let me know.